So last time we talked about the demand curve, and we discussed that the demand curve is downward sloping. What I'd like to do this time is take a look at one of those reasons why we model the demand curve as downward sloping, and that's called the income effect. Now, the income effect is one of those things that technically is named correctly, but it causes a lot of confusion. The income effect says that as prices rise, people feel poorer. They can afford to buy fewer goods and services. And as prices fall, people feel richer. They can afford to buy more goods and services. And it's really saying as prices change, it affects people's real income. But we hold their nominal income or their money income constant. So in the example that we looked at, the consumer had $10 and the price of a Pop-Tart was $2. What happens if the price changes, but the income, the amount of money they have, stays the same? Well, their purchasing power changes. So let's take a look at our model and see how that impacts the quantity demanded. So if you remember from our consumer choice model, we had granola and Pop-Tarts, and the price of granola was $1, so with $10 we could afford to buy 10. And Pop-Tarts were $2, so we could afford to buy 5. And we had this budget constraint that connected those 2 points. Those are all the combinations of granola and Pop-Tarts that we can afford. Then we looked at an indifference curve, and remember the indifference curve is all of the combinations of granola and Pop-Tarts that keep our total utility constant. So every point on this indifference curve has the same level of total utility. In this case, that's 770, and it comes from, remember, the 2 choices that we were making. 4 units of granola gave us 330 units of utility, 3 Pop-Tarts gave us 440, and that gives us a total utility of 770. And that optimal point then is represented on the graph at 4 granola and 3 Pop-Tarts. That's the highest indifference curve that we can reach. So as we think about then the demand curve is that relationship between price and quantity. What would happen if the price of a Pop-Tart changed? So remember, originally a Pop-Tart was $2. What if that's now $1? Well, this point here on the budget constraint, that would move out. And so imagine it's out here. That's now 10 units. And we could connect sort of those 2 points. Assume that that's sort of there. This is now that new budget constraint. And you'll notice that that indifference curve that we had, that 770, touches that budget constraint. That would be spending all of our money on granola and Pop-Tarts and getting that same level of utility. But this implies that there's actually a higher indifference curve that we could reach. And if we went through and looked at how would that optimal bundle change, well, now at a price of $1, we could afford to buy more goods and services, and what we would find is that we would get 5 granola and 5 Pop-Tarts. The 5 granola is going to give us a higher level of total utility, and so that's now 380. The 5 Pop-Tarts will give us a higher level of utility, that's 610, and the total utility now is 990. That means this new indifference curve has a total utility of 990. All of the combinations of granola and Pop-Tarts on that indifference curve give us that same level of total utility. And so this point here is now that 5 granola and 5 Pop-Tarts. And one question for us to really think about then is this change in that optimal point really comes from 2 pieces. You'll notice the slope of the budget constraint has changed, right? The relative prices of the 2 products. But it's also moved outward, and that's really the income effect. The income effect says that we feel richer or feel poorer resulting from that change in price. And if you remember, if we really did change the person's monetary income, instead of, say, having $10, if they had $12, that would shift the whole budget constraint out. But it would be a parallel shift, right? Because you could afford more of both products. Well, what we can do is really imagine that same change, right, a parallel shift, but keeping the relative prices at that new ratio, right? Pop-Tarts at $1 and granola at $1. That would be a budget constraint that's parallel to the new budget constraint. But what if we drew that on the original indifference curve, right? So this budget constraint it's imaginary. It's as if the price of granola and Pop-Tarts were both $1, but basically having less than $10. And this point gives us a total utility of $7.70. Well, that point then would kind of get us from sort of 3 to some increase. Right? So if we were to go through and we have the chart, if we were going to go through and look at what combination of granola and Pop-Tarts would give us 770 units of utility, it turns out that that would be around 2 1/4 granola that would give us 215 units of utility, and about 4 1/4 Pop-Tarts, and that would give us about 555. You'll notice this is still 770. In this new allocation between granola and Pop-Tarts, you'll notice something, right? That from our original optimal point, we're buying less granola and more Pop-Tarts. That should make perfect sense because the price of a Pop-Tart is now lower, so consumers will look for the cheapest way to satisfy that need for hunger. And that's this point here. So what we can see is then that this amount of Pop-Tarts here is about 4 1/4. And the new optimal point has 5 Pop-Tarts. So if we were to look at the difference between those, sort of 5 Pop-Tarts and 4 1/4, that's about 3/4 of a Pop-Tart. This is the income effect. It's the change that comes from buying sort of Pop-Tarts from the relative price changing, but now focusing on the fact that you feel richer, that your ability to buy goods and services has increased, that we can now increase the total amount that we're buying. And that's that sort of shift from 4 1/4 to 5 units. Next time, what we'll do is we'll take a look at the substitution effect, another of the main reasons that as a price change, people will change the quantity that they're demanding.